Hey everyone, welcome back to our channel. Today we will see how to mesh the region between a 2D spur gear and the casing. The gear we choose has 20 teeth. The strategy I plan to approach is to create a topology for one tooth with periodic boundary and reflect the mesh for the whole gear. In this video, we will learn how to create a blocking structure for a gear, how to create a 2D periodic boundary for rotationally symmetric geometry, and two ways on how to generate a full grid from a periodic topology. Block building. First, we will create faces along the top plan resembling the shape of the addendum circle for two consecutive teeth. Considering the center of the teeth line to be the periodic boundary, the corners are created only till the center of the tooth top line. We will next extrude these faces to the housing by grouping the corners into corner group and wrapping. Reposition the wrapped corners into the meshing domain outside the gear. Now we need to create a block along the working depth. Create a face near the addendum circle and link them with the face on the top to create a block. The blocking created so far is a base blocking because we still need to address some quality concerns in the blocks emerging from the gear. The block corner at the edge of the top line has three blocks emerging out of it. This is not ideal because we are creating a non-orthogonal condition here. Ideal condition for orthogonality states every corner on the surface should be shared only with two blocks. Similarly, if we come closer to the addendum circle or base circle, we can notice that the two adjacent faces of the same block are assigned to the gear. This will force a triangle at the face-to-face intersection. To resolve the above-mentioned singularity issue and to generate a O-structured grid, we will wrap the singular edges so that those points are pushed into the volume and are not assigned to the surface. In GridPro, when two connected corners are selected in a group, the connected edge is also a part of the group. This is a convenient feature in many cases, but here it has also selected an interior face. To exclude the face, I will drop an insert through the middle and remove the interior corner and do a boundary wrap. Let's reposition the corners such that the blocks are created only in the region where we want the mesh to be generated. And complete the assignment for the gear tooth and the casing. Density adjustment. Switch on preview to visualize how the grid will look. The depth of the teeth and the other edges have the same number of cells, so we increase the density in that region. Also, the edge representing the addendum circle seems to be thrice the length of the addendum circle. To address this, we split the block at almost the center of the working depth. Add the interior corners of the top half into a corner group C6 to perform an internal wrap. After performing the wrap, reposition the corners so that the wrapped layer is positioned at the center. Now recheck the density and adjust them accordingly. Check the validity of the topology. It will give you a fully valid topology. Let's run grid for 500 sweeps and load the grid. We have a grid of good quality with a maximum skew value of 0.56. To create a full grid from a periodic grid, select the transform option under Edit. Choose Mirror Periodic and click on Transform. A full grid would be generated. In many scenarios, the gap between the gear and the housing may be asymmetric. In such cases, we want to create a full topology and generate a grid. To create a full topology, group all the corners into corner group C5. Go to Edit, Transform, Rotate. Change input as periodic topology and click on Apply. Now run grid and load the full grid into the UI and check for quality. Here's a quick summary of the tutorial. In GridPro, we can create full grids for gears by either reflecting a periodic grid or by reflecting a periodic topology. With this, we come to the end of today's tutorial. Have a great day. If you have any questions or any comments, feel free to leave it below. If you want us to post tutorials on any specific geometries, you could write to us on support@gridpro.com. Thank you for watching. If you like this video, leave us a like and subscribe to the channel for new videos. Follow us on our social media pages. The links are posted in the description.